Hey folks, let's review some of our exponent rules. So we're going to see the product rule, the quotient rule, the power rule. We're going to have some negative exponents and maybe even an exciting, zesty zero exponent show up. So I'm going to work through a couple of these, kind of talk through how I would solve them. I see that these are being multiplied together, so I have the product rule coming around. And after I drop my eraser, I'm going to see x to the third times x to the second, and according to my product rule, I get to add the exponents. I see y to the fourth and y to the third. According to my product rule, I get to add the exponents. So this should simplify out to x to the fifth and y 4, 5, 6, 7. And that is simplified. I do not have any negative exponents. On this next one, I'm going to go ahead and deal with my coefficients first. I get a -4 and a 3, which is, so I have a -4 times -3 because we're multiplying together. So that's going to be -12. And then I'm going to deal with my x's. So I have an x squared and x to the first. So that would be 2 plus 1. So I have x to the third. I've got a y to the third and a y to the first. So that's 3 plus 1, so it's y to the fourth. And I've got a z here and a z to the second, so that's z to the first plus the second, so that's 1 plus 2, so that's z to the third. And there's no negative exponents, so this is simplified. I can leave this as is. This negative right here is telling me that the whole value, all of this together, is negative as of right now. All right. Let's go on to the next one. This is a power-to-power rule. So that means this 3 is going to distribute to all three pieces. So I have -5. Notice the negative's in the parentheses, so I need to include it. That's very specific, and that's an important detail. And I have x to the fourth to the third, and I have y to the second to the third. And notice the 3 is distributed to all pieces. So -5 to the third power is -5 times -5 times -5, so it's going to be negative 125. That's fully simplified. I have x 4 times 3, which is x to the 12th. And I've got y, which is y 2 times 3, which is y to the 6th, and that is simplified. So my power-to-power rule tells me that I get to multiply exponents. My product rule tells me that I get to add the exponents. All right, so let's look at division. This is our quotient rule. Now, why this says assuming no denominator is equal to 0, remember, we can't have a 0 in our denominator. Anything divided by 0 is undefined. Just S series. So, same base, dividing, so I can then subtract my exponents. 9 minus 6. So I end up with y equals 9 minus 6 is 3. That is simplified. Okay, now we got this one, number 9. A lot of people have questions on it because you have coefficients here, 6 over 8. How do you handle that? Well, 6 over 8 simplifies down to 3 over 4. 3 in my numerator, 4 in my denominator. Now I can keep moving on. Let's see, x to the fifth and x to the second. So it's x to the fifth minus, because I'm dividing, 2. So I end up with x to the third. And x to the third is positive, so it's going to end up in my numerator. Let's deal with the y's. I have y to the seventh, so this is my y's, to the seventh minus 10. 7 minus 10, I end up with y, I end up with y to the -3rd. It's negative, so it's going to end up down here, y to the third. And then my w's over here, so I have w3 minus 3. It's going to end up with w to the 0, which equals 1. So this is my final answer. 3x to the third, 4y to the third. If I kept all the pieces just lined up, I might see it like as 3/4, and I have, so I have to deal with my 3/4, and then I end up with what, x to the third, which I knew was going on the top. I had y to the -3rd, which I knew was going to go on the bottom, and I had w to the 0, which I knew was clearing out. So top, cleared out, bottom, bottom. Okay, scientific notation. We need to write each number in scientific notation. Remember, my first piece of my scientific notation, the number needs to be between 1 and 10. So I got to put my decimal here because 5.76 is in between 1 and 10. I always have the times 10 piece to it, and I need to figure out how many times I need to communicate how many times I move my decimal. So 1, 2, 3, 4. When I move left, my value goes up. So left begins with an L, not an F. So left is up. So I said 1, 2, 3. I moved 4 places. So I need to write this number in decimal notation, which means standard notation. So this -3 tells me that it's small. So I need to move this. This is going to tell me I'm going to move my decimal to the left now. So if I do move my decimal to the left, 1, 2, 3, in decimal notation, it's 0.1, 2, 3, 0, 0, 6, 4, 8, 7, 1. Now notice it was here, and I moved it 1, 2, 3 places in order to get it in decimal notation. So we got to evaluate scientific notation as well. We should be able to do that. Right here, I'm going to deal with my exponents. Let me grab a calculator. All right, when I take 7.2 divided by 4.5, I get 1.6, so I am literally dividing those ones. But these guys, I get to use the quotient rule because they have exponents and they have the same base. So I'm going to say times 10, and I've got -5 minus, because of the division, 2. -5 minus 2 is going to be -7. And there it is. Now for multiplying scientific notation, same concept. I'm going to take my two coefficients, 3.5 times 8.2, and I end up with 28.7. And I'm going to take my bases, same bases, and with exponents. So it's times 10 to the 6 plus 3 using that power rule. Now, if you notice, 28.7 is not between 1 and 10, so this is not in scientific notation. I do need to move my decimal over 1, so it's 2.87 times 10, and because I moved my decimal to the left, this exponent has to go up. And there is my answer. Okay, we're going to simplify a few of these. I'm just going to pick a few that might be a little bit interesting. Again, assuming no denominator equals 0 because that's undefined. Like number 21 looks interesting because that 4 is going to distribute to both. So it's 2 to the 4th, r to the 4th, over 2r to the 4th. And I can already see here that the r to the 4th have the same base, so it's 4 minus 4, which is going to be 0, so those actually are gone. And I have 2 to the 4th over 2, same base, so it really can be 2 minus the 1 that's happened there, so sorry, the 4 from here, minus the 1 that's here, so it's 2 to the first power, and I end up with 2 to the third power. And I can keep simplifying because it says simplify, so I have to keep going. So 2 times 2 is 4, 10 minus 2 is 8. That's going to happen on 26. It looks like on number 16, this negative right here is going to tell me that the whole thing ends up being negative. I'm going to be left with that. Let's look over here. Let's look at 14. This looks interesting. All right, so I've got 6 over 15 and -6 over -15. Now, a negative divided by a negative is going to be positive, so I can actually clear out those negatives. So my whole thing is going to be positive. 6 over 15 can reduce, maybe by 3. So 34 by 6, so that's 2, and that is 5. Okay, and then I've got p to the first minus p to the first, so p actually disappears, it goes away. I have q to the second minus 1, so that is q2 minus 1. I end up with q to the first, so my q is going to end up in my numerator, and that it is. That's it simplified. 2q over 5. At 29, a little interesting. Now this actually does have a coefficient. It's showing up right there as a -1. Okay, and that 9 is going to be distributed to all the pieces here. So technically that right here, so that's like a -1 to the 9th, x to the 9th, y to the 9th, all over x, y to the 9th. And these y's will go away because 9 minus 9 is 0. Look at the x's here. So with the x's, same base and division, so that's x 9 minus 1. So I'm left with x to the 8th, so that's going to be my numerator. And for my negative 1 here, to the 9th power, so that's like negative 1 9 times, so it's going to stay negative. So this all simplifies down to, you could say it's like negative 1 x to the 8th. And to even simplify it the most, it's going to be negative x to the 8th power. Okay, I'm going to look at a couple more here, like number 20, like I got 39 over 52. So I can look at 39 over 52, and I can see, you know what, that it simplifies all the way down to like 3 over 4. Okay, I'm going to look at my x's. So it is 3 minus 2, so it's x to the first. So that's going to go on the top. I've got 2 minus 1, which is y to the first, so that's going to go on the top. And I've got z, and it's staying alone. So that is what it looks like. It should be 3xyz all over 4. 15's got a negative divided by a negative, so that whole thing will be positive. Keep track of that. I've got a c that's going to stay on the top. I have a b that's going to stay on the bottom because there's no negative exponents to tell me to do anything else different to it. What else is anything in here? All those look interesting. Let's see if there's another batch to look at. 9/12s. Very similar. Oh, let's look at 28 because we got that negative kind of hanging out again. So we can have like a negative 1 to the 7th, and a to the 7th, and I've got a negative 1 to the 4th, and a to the 4th. Those are being distributed out. So when I look at my a's, it's a to the 7 minus 4, which is going to be a to the 7, 6, 5, 4. That's like to the 3rd. Okay, so that's going to be in my numerator. Let's look at my 1's for a second. Okay, so I have negative 1 7 times. Oh, they have the same base. I can run that again. Okay, so let's look at this. They have the same base, and it's 7 minus 4. Let's see what this does. 7 minus 4, 7, 6, 5, 4, 3. So it's negative 1 to the 3rd power. So that's going to be like negative 1. All right, and notice this isn't negative, so I'm going to keep it at the top. So this whole thing ends up equaling negative 1 a to the 3rd, or negative a to the 3rd. Now, if you were a smart cookie, you could have seen like that these are negative right away. So you could say negative a, the whole thing, 7 minus 4. I wish I saw that because that would have been like so much faster. So negative a to the 3rd, so much faster, 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 faster. Let me see if there's any more I want to talk about. Let's look through some of these. You know, I had a lot of people asking me about number 5 on this one. Okay, number 5 on this one, I'm going to look at all my coefficients. Okay, so I have a 1/3, a 2, and a 6. And I'm going to do 2 times 6, and I get my 12. I'm going to multiply that by 1/3, and I end up with 4 as my answer. So now that I have my 4, I'm all set with my coefficients. Now I'm going to deal with my other things. So a to the 3rd, there's only 1. Excuse me, and I have a b and b to the 3rd. They're multiplying, so I get to add them up, and that's b to the 4th. Let's take a look at number 9, because why wouldn't you? A negative divided by a negative will be positive, so I'm going to leave those alone. Just pull the negatives out. So 10 over 14, I can make that 5 over 7. I'm going to look at my m's. Okay, so that is like negative 1 minus negative 7, and that's going to be like, this is actually the same as adding. So it ends up being 6, m to the 6th, which is going to be up top. My y's are right here, and I end up with 0 minus negative 3, so that's a 3, so that's going to be on the top, y to the 3rd. And I got an r right in here, so it's an r to the 1st minus negative 4. So that's actually 5, so that's the positive, so that's r to the 5th. So this ends up being 5 m to the 6th, y to the 3rd, r to the 5th, all over 7. Let me check if that's the right answer. Woohoo! That's what I got. Sweet bucket of lava. All right, keep practicing this stuff. I did post the answer key, so you can take a look. Have a great day, you and your exponential friends.